Hello, everybody, and welcome to another episode of Databases for AI, the only show that I'm aware of that focuses every single week on all the various use cases that you can launch and build and ship into the world leveraging database technology. People, when they think about AI, think about inference, but databases are such an essential part of that stack. If we haven't met yet, my name is Trevor. I'm a solutions architect here at Amazon. And I'm joined today by one of my favorite guests. I almost said my favorite, but I have to bite my tongue because I don't want to offend anybody. Melissa, introduce yourself to the people if they haven't met you before.
Yeah, sounds good. Thanks, Trevor. Hi, everyone. My name is Melissa. I am one of the Neptune specialist SAs here at AWS. So I focus on everything graph related.
Graph related. Well, guess what? Today's stream is going to be graph related. So good thing you are here. By the way, just so folks know, I see our friend Lauren coming in from Jersey City. I'm coming at you live today from the wonderful, warm, tropical greater Boston area. Melissa's coming at you from the always sunny Seattle. Let us know if you're dialing in today, if you're tuning in, where are you coming out from? It's always nice to know where folks are listening in from, Jersey City and beyond. Today's going to be, by the way, we got some other friends from Seattle. Would you look at that?
Yay.
Today, the stream is going to be all about building a recommendation engine, which, by the way, I'll just say, I thought would be very difficult and complex. But it turns out after talking to Melissa, it's just a few lines of code with something like Amazon Neptune, which is what we'll dig into today. Where by the end of the show, you should have learned how to implement your very own recommendation system. We'll walk you through the queries, and then we'll even close on how you can plug that into your own AI agent if you chose to do so. So I'm excited for this one, Melissa. I was like really, the demo that you showed me before we went live has me kind of buzzing. I'm like, okay, this is like really interesting.
Yep, absolutely. And I think in general, when we think of recommendations or you want to build some type of recommendation system, I feel like a lot of times people will think of some type of AI service that is maybe, or an AI model that's been trained and then pre-trained on some set of data so that when you do make a call in, right, like given this user, what should I recommend them? It's almost fixed in a way versus with graph, right? And we'll show this later on, you can have your recommendations kind of stay up to date as you are continually adding new data into the graph.
100%. And that was what took me by surprise, was like when prior to talking to you, when I thought recommendation engine, I thought training a classical ML model, which I try my best to be a data scientist, but training an ML model takes a really particular skill set to do well. And I'm excited to share with folks that it actually is not so challenging to build some kind of almost more of like a rules-based recommendation system based on a graph architecture. But I guess before we get into the nuts and bolts of the trade-offs here, I was thinking a recommendation engine is a pretty broad thing. It's a capability, but it could deliver for so many use cases. So I'd be curious to get your top of mind on what sort of recommendation engines you tend to run into with customers, right? Like I assume they're built on graph, but what are the type of use cases that you see these powering, Melissa?
Yeah, so I feel like we see a lot of kind of your classical like product recommendation types of systems. And when we say product, this could mean like an actual physical product, like what you'd buy off of retail platform. It could be a product in the form of like if we think about educational learnings, like selling courses, like e-courses or trainings, things like that, right? Like those are products as well, which you can build recommendations for. You can even have recommendations for things like in social networks. I know
Yep.
social networks is kind of the classic example, but it just works so well. Like recommending who you should be friends with. So really, I think the common thing that all of these use cases have in common with each other is that you are utilizing connections, right? And for those of you that haven't worked with graphs before, essentially a graph is just a collection of nodes and edges. And if you want to make some recommendations for something, it's really just equivalent to what we call a graph traversal. So you start at one or maybe a handful of starting points in the graph, and then you're going to kind of walk across those edges according to some logic that you're going to define for your recommendation rules and then return your results.
Yeah, amazing. And it's funny, ever since I heard we were doing this show, I've just been thinking about, and I've been seeing recommendation engines all over the place. Like whether you go to lovelyamazon.com and you're being recommended a different product. You mentioned the recommended of friends. I'm unfortunately I'm on LinkedIn way too much, but I certainly get a lot of great friend recommendations there. Lauren brought up one of my faves. I also spend way too much time on YouTube, and I love the recommendation engine that I get from YouTube on videos similar to videos I've watched or content that I'm interested in. So it's one of those things that is it's like a pretty broad surface for where you would want to input this. And I feel like it's inclusive of anytime you're trying to serve up a product or content or something like that to end users. I haven't personally seen this, but I could even reason to believe it could be used in a corporation for like internal, like recommending similar documents or resources or something like that. In fact, you started this by talking about one of the big differences between, or another way that some people might implement a recommendation engine is with a machine learning model. But if we contrast like that against something like a GraphDB, what seems really interesting and what caught me was you don't need like a massive clean, well, you probably need some cleaning, but you don't need like a massive data set to do a machine learning run, right? You obviously need data that you can query in the GraphDB, but the fact that you, like, a lot of applications may not have, all of the retroactive videos that somebody's watched or products that somebody's bought to be able to train a classical model. And so to be able to do this without going through that process, or not train it, to be able to build this capability without going through that process seems like a good way to start. Maybe if you're building like your first recommendation engine and you don't have like a machine learning background.
Yep, absolutely. And I think especially in scenarios where part of the recommendation logic is based on some predefined knowledge. So for example, if let's say I run an ed tech platform and I sell like different learning courses for students, and then there's different topics like math and science and physics and things like that. When I'm recommending courses to a student to purchase, there is going to be some element of like, what topics is this student particularly interested in? So that kind of influences their recommendations. But also at the same time, there's almost like a set path of learning that needs to play a role as well. Because, for example, let's say that we know this student is generally interested in physics, and a very popular, hot, top selling new course is on quantum mechanics. Well, if the student who likes physics, it kind of makes sense to recommend that to them. But if they haven't even completed like basic classical mechanics yet or electromagnetism, then you don't want to recommend them a course where they don't necessarily meet the prerequisites. Or, there's kind of like a natural order in the courses that this person should take. So I think especially in those scenarios where there is some defined logic or rules around how certain recommendations should be generated, like that information can be deterministically captured within the connections of a graph, versus trying to make sure that your ML model is trained to make sure that they will always obey these types of rules.
Right. Yeah, that makes perfect sense to me. You know what? I'm wondering, because these systems are so common. Let's see if the folks in the chat have been listening. I'll hit the chat with a question. Can anybody think of a recommendation engine that we haven't mentioned yet? That's question one. But if you can't, throw out a recommendation engine that we've already mentioned. All right. But I'd love to hear if anybody else has ideas or has seen use cases for recommendation engines out there. beyond, I think, the ones we already discussed, like
Yep.
video recommendations, product recommendations, and hey, Lauren's got a good one. Lauren has a good one. I like that one. What about dating apps? I would say that's
Yeah.
that is certainly a recommendation engine. I met my wife on a dating app, actually. So I say what you will about them. I like whatever recommendation engine folks are using for dating apps. It worked well for me. Oh yeah, post recommendations. There we go. Post recommendations is a nice one as well. So yeah, I mean, people get the idea, right? The kind of archetype of a recommendation engine that is out there in the world, and when you might think of implementing it into something that you've built. So, all right. So we've talked a lot about how you can use a recommendation engine. I think today we're going to walk people through the next 50 minutes or so. We're going to walk people through how to actually bootstrap a recommendation engine. And we're going to look at this through the lens of a use case of restaurant recommendations. So Melissa has done the amazing work of building out or reusing an existing data set actually to build this flow. And if you wanted to, you could take the same data set, follow along step by step with us to build your very own recommendation engine to learn this for yourself. So any thoughts from you, Melissa, before we dive in and kind of start walking people through the data set you've built for them?
I would just say, we're going to be focusing specifically on restaurant recommendations, as Trevor mentioned, but, throughout the demo, we're going to try to draw parallels between, this data set that we're using, the specific one, and then kind of like generalize it to other situations, because at the end of the day, recommendations are all about connected data, and whether or not the business logic you want to express is going to be best handled with kind of a connected data query. So even though our use case today is like very, very specific to this restaurant data set, it's definitely the themes and the concepts and techniques that we're going to talk about are totally applicable to other use cases, industries, verticals, domains.
Love it. I love when you learn a new skill and you can apply it to different projects. That's those are always my faves. So, cool. Well, Melissa, let's get started today, and we'll pop your this doc you put together for us up on the screen. Let's start by what is the data set that you use? Is this actually? I see Yelp. Is this actually from Yelp, like the well-known?
Yes.
Oh, cool.
Yeah. So for those that aren't familiar with Yelp, Yelp is like this online ratings platform where people can review and rate businesses. I think Yelp is global, but it's primarily used in the United States. So as we go through the data set, you'll see that the bias is kind of shifted towards businesses in the United States. But they made a subset of their data open, I think a few years back ago now. So all the data that we're going to be working with today is real data, which is always fun to work with. I just want to walk you all through what the original starting source data set looks like, because I think one of the challenges of getting started with graph, if you haven't done a lot of work with graphs before, is kind of like, how do you do that mental model or the mapping between a non-graph data set into a graph? And so that's why I always like to start with our source data set and just show you, what did we start with today. So we essentially started with this Yelp data set, and they provide it in JSON format. And I'll kind of just give you a high level of what's contained in it, and then think about how we do the mapping. So essentially, there's really 5 main categories of data that they provide. The first one is businesses. So for each business, they've got, some unique ID. There's the name of the business, some geospatial information about the business, as well as there's some attributes as well. So the attributes can vary. For example, not all businesses will have the exact same attributes. It's really just a JSON statement of some attributes that are selected. we've got some categories. So I'm going to specifically call this out because this will be important for us later on. But this is just a collection of like generally what category does a particular business fit in. And then, of course, you've got some hours. The other important data that they provide is going to be reviews. So if we are wanting to do a restaurant, or I guess technically a business recommendation type of use case, reviews are going to be critical for us because they contain not just the star rating that someone gave it, but it also includes a text string of what that person actually said about that business for that review. You'll notice that for each review, in addition to, of course, its unique ID, we also have the IDs of the user that wrote it as well as the business.
You know, you brought up a really good point, Melissa, that is probably worth, if you're exploring a recommendation use case and that's how you stumbled across this video, it's probably really important early on in the process to think about what is the attribute of the thing I want to recommend that I will generate the recommendations based off of, because I could see a world where there's a data set that actually doesn't have that context that you need, right? Like if this data set only had like hours, name, and star rating, the recommendations wouldn't be so rich. It would, you know, you would basically say like, here's other restaurants that are open at the same time with similar stars, which probably isn't the level of personalization that you're looking for if you're building something like this. So it's a great call out of like early in the process, you can be applying your knowledge of graphic learning from these shows to make sure that you actually have a data set that has a potential to generate the sort of recommendations that you would like.
Yep, absolutely. And that's also one of the reasons why when we kind of generally talk about how do you get started with modeling a graph use case, we're always like, work backwards from the business questions that you want your graph to answer. Because once you've kind of outlined at least a handful of the top most important questions that you know you want your graph to answer, that'll kind of give you a sense of like, what information do I even need to keep in my graph to be able to answer those questions? So for our business logic here, if we wanted to be able to make business recommendations based off like ratings and also user interactions and user to user interactions, kind of like that social aspect, we need to make sure that our data set that we're using contains those elements so we can actually put them in our graph.
Makes sense to me.
Awesome. So the last one that I'll focus on, there's actually a few other categories, but these are going to be the key ones that we're going to be working with. The last category of data that they provide is user, which is going to be super core to what we're trying to do. And each user entry contains, of course, the user ID. There's some extra metadata about that particular person. And of course, what's really key here is you also get a list of who their friends are. Right. So now you can kind of start to see where the connections are going to be, right? Because it's like each user, if we say each user is a node, they're going to be connected to each of the users in their friends list, right? Because we've got that kind of connection there. And even if we go back one step to the reviews, right? Each user wrote some review about a business, right? So now you're starting to stitch together. You have user to user connections, user to review connections, and then you've also got review to business connections. And then from the top level, we saw you even have business to category type connections.
And so now that we've level set on the connections in the data, I guess it seems like what we could do is use the actual written review. Obviously, we could use the friends that you have, and that seems like maybe there are other attributes here, maybe the rating just as a filter to make sure you're getting quality results. But I can start to see how we could piece these different parts of this business data set together to build out a recommendation engine.
Yep, absolutely. And that is exactly the model that we're going to be using. So let me actually swap my screen just so I can show you all what that model is that we're envisioning. And I'll show it on my notebook just so we can see a nice polished picture. And then we'll talk through like how did we even get from a bunch of JSONs to this nice looking graph.
Wow, that is a nice looking graph. That is for sure.
Yep. So what we're looking at here is basically a snippet of what the final graph model looks like based off of all that JSON data that we started with. So I'll step back a bit and talk about that flow of like how you'd actually do the transforms, but just to give you all the mental model of what the final product looks like, this is kind of what that looks like, right? So you've got each user is going to be their own node, and then they can connect to other users through like friendship edges. You'll have each review, which is going to be the stars. Those are also going to be its own nodes. And then you can have, each person wrote a different review. A review was about a certain business, and then, certain businesses are connected to different categories. All right. So now it's like, the big question is, of course, like, how did we get from JSON into this nice format? So there's a lot of ways to do this. Personally, what I did for this is because we were starting with just a bunch of JSON documents, I actually just used a Python script to basically say for each JSON element in each of those category documents, generate a new CSV file to represent each like business, user, review, etc. as its own node. The reason I'm writing it out into CSVs is because I am using Neptune as our graph store today to store all of this. And one method of ingestion into Neptune is through what we call bulk ingestion, which is essentially just formatting all of your graph data, like the nodes and edges and properties, into a CSV format, drop it into an S3 bucket, and then it'll just load it all. So that's the reason why I'm using a script to transform into CSVs. If you were starting with something like very rigid and very structured, for example, like relational tables, if you've got them in like Iceberg and accessible through Athena, so kind of hinting towards last week's episode where we were talking about data lakes or graph analytics over data lakes. If you've got more of a rigid data set like that, you could use a tool like our open source NX-Neptune on our GitHub, which does provide an easier way to do the ETL. Essentially, behind the scenes, you can provide it some SQL queries that will kind of do the mapping between your source data and then the desired nodes, edges, and properties, and then it'll do all the extraction and transform and load into Neptune for you. So different ways of doing this. I just did the Python scripts, of course, with the help of Bedrock, actually, which is actually really quite good for that. It was super quick. I was just like, write me a Python script to transform XYZ given ABC JSON, and it was pretty good.
No, it's great, especially if the data set as long as you can, the data set isn't so big that you can run the script locally. That's like a super quick and easy way to just get data in the right format. One question I have before we move on is how many end tables did this end up being? Like how many different CSVs did you end up with to build the graph data set ultimately?
Yes. So for mine, actually, I think I can show a few. So so I ended up breaking it into a few different CSVs based off of the label of the node. So the label of the node is essentially, it's kind of like a way to categorize different types of nodes. So for example, our graph, we have business labels, users, reviews, and categories. So I personally like to break them up by label just because it's easier if I need to just like check something out really quickly. But from a Neptune perspective, we really just require one or more files to represent nodes and then one or more files to represent edges. So there's like a certain format that we expect to be able to be parsed as a node versus an edge. So that's really the minimum requirement, but I like to keep things organized.
Those aren't small CSVs, 3 gig CSVs. Those are you were crunching some numbers there on your laptop. Okay, cool.
Yeah.
Cool.
Just to give us a sense for folks about what is in the graph in terms of the count. So if you are interested in working with the Yelp data sets, if you go with the model that we've proposed, user nodes, business nodes, review nodes, category nodes, you end up with like 27.5 million total nodes and like 123 million edges ish. So the scale of the Yelp data set, it's a pretty decent size.
Yeah. Very cool.
Awesome. One other thing I'll mention about the transformation as well, before we move on to actually start making some recommendations, is one thing that I did not show here is that behind the scenes, as part of the ETL process, we're actually also generating vector embeddings for the text of the reviews. And so this is kind of a throwback to our first episode together, Trevor, where we talked about hybrid queries with vector search and graph search. And there's a lot of, I think, really good data that is hiding in that like text box of people's reviews. And we really want to be able to kind of like tap into that and leverage that as well. So we've pre-generated some vectors to do.
That makes perfect sense because that then gives you a nice numerical representation for like which reviews are similar to one another, right?
Yep.
So that makes a lot of sense.
Yeah, absolutely. And as far as the architecture goes, for what I'm showing today, I really tried to keep it as simple and streamlined as possible. So I'm actually using Neptune Analytics today, which is one of the graph databases that's part of the Neptune family. And in addition to acting as a graph store, it actually has its own vector index as well. So I can store the vectors together with the graph, and it's easier for me because it's like less infrastructure to worry about. But for other folks, you can totally split it up if you want. If you wanted to have like Neptune database as your graph store and then Opensearch as your vector store, you can mix and match. But for me, I like to keep stuff in one spot. So, all right, should we start making some recommendations?
I think let's that's what I'm really curious to see now is like, because you've got all the data prepped. But like exactly how do you string together these different queries and stuff is, I think, really, because this is where it becomes very unique to your specific recommendation approach, right? Where you're kind of like deciding what are the sets of rules or filters that we bring this through to get to a good recommendation.
Yeah, absolutely. And that's exactly what we are gonna walk through today, because as you mentioned, I think when it comes to recommending a restaurant or a business to someone, there's a lot of different factors that you can kind of consider in order to make that recommendation. And then they all have their own different logic. So kind of starting with the first one, in general, if we want to do some type of business recommendation based off of not just what I've highly reviewed, but if I have friends, I feel like generally most people's friends have some sort of overlapping similar interests. And so when you're considering whether or not you want to go to a business, if your friend has some input on that business as well, I feel like that, it generally sways you at least a little bit. And so that is what we are doing here today. So, let's say I want to find some recommendations based off of, consider what I've already rated highly, and then also make some considerations about how my friend has rated that location. So I'm going to be going through all of these, what we call these Open-Cypher queries. If you're not familiar with Open-Cypher, it's essentially the open source subset of the Cypher query language. And it's a very declarative kind of like pattern matching type of query language where you can see the way that we define the graph patterns we want to match in the graph. It's kind of like drawing ASCII art. So when you see the open and closed paren, that's like representing a node. And then of course the little dashes with the greater than or less than symbols is going to be like the arrows that are, or the edges that connect different nodes together. So that's kind of how you would read these types of queries.
Got it. And a relevant question from the audience was like, I think they're asking, I assume based on the filters here, you could say the rating is 5 stars, but I'm sure there's some query to say it is 3.7 stars or greater, right? Like I'm sure there's some, okay, that makes sense.
Oh, yep, absolutely. So you can definitely add filtering to this. And I think filtering and adjusting those thresholds is also kind of a key part of how you want to define the logic for your recommendations. So here I've got, I'm just going to set the bar really high. So we're going to say for this person that I want to make some recommendations for, let's just see what they've rated a 5. So they've rated quite a few places a 5 stars. So if I want to start maybe recommending them places that are similar to what they've rated a 5, yet still those recommendations are related to places that their friends have been and also rated highly, I'm going to implement some logic like this. So the way that I would read this is essentially first, we are going to find all of the 5-star reviews of this person. I'm doing a quick little call here. So just to be fully transparent, I think there's like over 2 million reviews in the graph. And so that is a lot of tokens to Bedrock. So I was trying to be frugal and I only generated vector embeddings for a portion of all those reviews. So that's what we're doing here. I just want to make sure that I do have a vector embedding associated with one of these 5-star reviews because I want to use semantic search in order to find basically other similar reviews to the 5-star reviews that this original person asked, because I'm going to use that as kind of the basis from which to make the recommendation. So that's all we're doing here is make sure that we're getting a review that has a vector to kind of compare against. For those remaining vectors, then we're going to do a top K search. So essentially, what are the top 10 other semantically similar reviews to my 5-star review? And then for each of those that we find, what business is that top K review associated with? And has that business been highly reviewed, highly in this case, I'm saying above a 4, by one of my friends? And then return something. So it's kind of a lot going on here, but it'll make more sense once we see the output.
It does. No, it makes perfect sense to me. And I imagine like even like the ordering that you do some of these things probably really matters a lot to the ultimate output. So you might end up tweaking this a little bit. But effectively, if I understood that, it's like we're basically determining, are the reviews similar semantically?
Yep.
We're basically finding, joining which semantic, like basically doing a lookup. Okay, these ones are semantically similar. What is the business associated with that? And then on top, once you have that list of businesses, it's ratings, connected friends, just like other layers within the data that you can use to further target the recommendation.
Yeah, absolutely. Yeah. And one reason for kind of considering the friends as well is there is going to be an aspect of, if I didn't have the friendship filtering, I could be recommending someone a very similar business that's like on the other side of the country, which you may or may not want to do. So to kind of keep the locality of the recommendations here, I am just assuming that most people's friends are like geographically close to them, which I know isn't always true, but a lot of times it is. So this is kind of a way to also kind of help account for the locality.
Well, and it's also a good example of like another layer or another piece of data that would be useful for a potential recommendation engine. Like I don't know if this data set had like a address or like a coordinate or whatever, but I'm sure there if you had that in your data set, you could use location or proximity as another input, like based on like how far is this place from users' current location. So, but it's also a really nice pragmatic example of how you can work around the lack of data to
Yes.
find like a MVP solution or like an initial solution, because sometimes getting those data points, when you find that you don't have a data set, it's oftentimes not as simple as just pressing a button. Like sometimes you have to go change business processes. So that makes sense.
Yep.
By the way, we got a question that would probably be good for you if it makes sense to you. Somebody's asking, is there like an exploration aspect to traversing the graph for a recommendation? I take that as like maybe how do you just explore a graph in some of the traversals, but maybe you take it differently. So curious what your thoughts are on that, Melissa.
Yeah, so there definitely is an exploration aspect. I guess when I think of exploration aspect, I'm interpreting that as, you're exploring or you're traversing a subset of the entire graph in order to come up with some recommendations. So in my mind, like a query like this kind of is a representation of that exploration, because, we're essentially starting our graph traversal at this person, right? So you can imagine conceptually, you've got this big graph and you're starting at this one node that represents this particular user. And then we're exploring the graph in the sense that, okay, let's explore and see what 5-star reviews they've written. So of course, based on the way that we've modeled our graph, users are connected to review nodes. So your first exploration or the first step of that is like user, okay, what reviews did they write? And then filter which ones, let's only keep the 5 stars. And then from there, that's when we are going to jump into the top K. So for the 5-star reviews that this person has written, do a top K. So we're essentially going to find 10 times the number of 5-star reviews that they've written. So I guess that's not really a graph traversal or a graph exploration, more of a vector one. Yeah. But after we find those vector starting points, then you're going to kind of pick up off of those different points in the graph and then continue on in the traversal, which is, okay, so for each of the top K that was surfaced, traverse the edges to find what business they're about, then traverse the opposite direction edge to find what reviews were written, and then one more inwards hop to find the users.
You know what? I wish we had time on today's show, because I would love to. Sometime in the future, I hope we can do a show where we deep dive into like the traversal process and also like all of, because like what's cool is the queries that or traversals, I don't even know the correct semantic for it. They're logical to me. Like I can read them and kind of understand what is happening here. But I imagine this is a super important skill set for folks of like, how do I move around my queries or what have you to explore things. Would you scroll down a little bit so we can look at the data set too? So like, let's say that if we just focus on this data set, this is basically like, I want people to visualize, right? This is the list that, let's say you're in the app that's recommending restaurants, or you're you're watching this on YouTube and you have a bunch of recommendations in the sidebar, right? Like this output is ultimately going to contain the metadata that, and the links and the things that render that view, right? So I just want people to kind of connect this with that concept. And I want to check to see if folks have any. I'm going to ask the audience a question. Are you ready, audience? Let's say hypothetically, you wanted to build something like this on AWS. I'll see if you've been listening. There's a hint on the screen even for folks. I'll even give you that hint. What AWS service might you use to store and then query the data to put it in this format? Let's find out who the first person who's not Lauren, who can give us the answer to this question. What is the AWS database service that you would use if you were thinking about building out a graph recommendation system like this? I'll give folks a few minutes. All right, we got a few folks that I think have been listening. We got Reginaldo. we got roaming here. We got Lauren dropping an incredible hint. I think it's a planet.
Yes.
I appreciate her not giving the answer, but giving a really nice hint. People have got it right. Saturn, hey, that sounds like a good name for the next AWS database service that we release. But for now, it is Amazon Neptune. What is the planet Neptune? I used to know a song. Let me think. Neptune's got those icy rings. That's the song. I learned about the planets from Blue's Clues, and so I wonder, is there history, by the way, in the name of Neptune related to graph? Like there must be some symbology there, right?
Yes. Oh my gosh, I can't remember the lore behind it. I actually want to say that we have a blog post that talks about the history of the naming conventions. I'll have to see if I can dig it up and then put it in the comments later. But yeah, I want to say it has something to do with mythology and some of the like the Greek gods, because I think there are other like graph services that kind of have a nod back to that mythology aspect. For example, like Janus Graph is an open source graph database, and I think Janus or is maybe like one of the moons or something of one of the planets. But yeah, there is definitely a tie back to mythology.
I love movies that have nodes to mythology, but like I actually know nothing about it. So yeah, Janus it is. Sure. Amazing. Great job, folks. I'm glad y'all hopefully folks have used these sessions to start experimenting a little bit with Neptune and running some of these queries. But very cool so far. Very cool so far.
Absolutely. And before we go to the next query, I just want to kind of show a little bit of proof here. So the column on the left is going to be businesses that this person highly rated. And then what's on the right is basically the recommendation. So just as an example to compare the outputs of the queries, right? So this first one that I picked, this is going to be the JSON data for Indianapolis City Market, which is, if we skim this, it's a great representation of Indianapolis, kind of like how Pike Place is to Seattle. And if we look at the recommendation, I look at the text, if you really want to get to know Indianapolis, you should go here. So that semantic aspect really captures the notion of like similarity between what people think is going to be like a key representation of their city.
That makes a lot of sense to me. Yeah, that's cool. That's a really that helps me understand because I think if you were looking at the data, if you actually looked at the raw query, wouldn't you just see numbers behind the scenes? So
yeah, exactly. So, you'd see like the vector distance, so you're like a number, but like
what does that mean? But yeah, this is very helpful to kind of see what the two why these are showing up as being similar reviews. Yeah. Oh, by the way, that brings up an interesting point that we didn't discuss yet. For those folks that are following along the thread that we've had about graph versus like a traditional recommendation model or like a machine learning recommendation model, what you just showed actually is a really good example of how easy it is to do explainability in graph, right? Because there's no model that's a black box. You're really just querying data that you've prepped and structured in a way that it can be queried, and these relationships are built. So if you have a use case where you're making recommendations and you really need the proof or the evidence or the audit or I don't know what the correct terminology in graph world is, but if you need that explainability or that audit trail, graph makes a lot of sense because you're going to have all of that data at your disposal.
Yeah. Absolutely. And this is just kind of a visual of, it's basically the same query that we saw just in a visual format with the results limited so I don't crash my web browser. But, that's kind of another aspect of explainability, right? Like now I can actually visualize. So the original starting user is one of these somewhere, but you can kind of get a sense for like the interconnectedness of the person that you're making a recommendation for with their friends, and then how similar ratings have been given for this particular business that you're recommending. So
very cool. Yeah. Very like in addition to having like probably like the raw transactions that you can log, like being able to explore the data in a visual setting like this is really, really handy.
Yep. Absolutely. All right. So for the sake of time, since we had some really good discussion, I'm actually going to skip some of the simpler queries and then jump to some graph analytics types queries. So the simple ones that we're going to be skipping here are going to be things like everyone knows like friends of friends recommendation. But how would you rank friend recommendations if you come up with a lot of them? So these are just examples of how you might consider re-ranking, either based off of like mutual friend count or kind of like mutual shared love of certain business or restaurant categories. So again, all kind of deterministic and explainable, as you mentioned, Trevor. All right. So the section that I want to spend a little bit of time talking to, because I think this is where a lot of the magic of graph is, that it's kind of hard to reproduce yourself on just like a key value store, is going to be running what we call clustering algorithms. And so essentially clustering algorithms are a class of graph algorithms that will kind of group together different nodes in your graph into different logical clusters based off of how connected they are to each other. And so there's a lot of different graph algorithms out there that have different definitions of exactly how certain clusters are defined to be generated. One algorithm that is very common for doing kind of segmentation and clustering by general similarity of connections is something that we call Louvain. And essentially, Louvain is going to be a graph algorithm that we can run, and it's going to generate clusters based off of how connected all the nodes in a given cluster are compared to connections outside the cluster. So if you're interested in the details of how it's implemented, you can just look up the Louvain algorithm. But essentially, we have kind of like a pre-built function in Neptune Analytics that will do this for you, which makes my life easier. So essentially what I did behind the scenes is I did what we call generating a kind of like a projection of the graph. So basically, let's say I want to generate some business recommendations, but first I want to basically make collections of people that have the same interests. I'm going to define interest in this case by the fact that someone wrote a review about a business, right? So I'm kind of inferring that if someone wrote a review about a business, that means they visited that business and they generally like it, which of course, looking back, I should have probably added some filtering just in case we have an overwhelming amount of people that rate businesses poorly a lot of times. So going back in time, I think I would add some review filtering on this, but otherwise, what I've done behind the scenes already is I've generated kind of like a projection of our graph that is essentially going to make these shortcut edges between a user and a business to represent that a particular user frequented a particular business.
Yeah, this makes a lot of sense to me, and I imagine there's like different algorithms you might use for different situations when you're going through this. By the way, folks, I just want to say, please keep the planet jokes coming. If you are just now tuning in, we're talking all about Amazon Neptune and how you can use it to build a recommendation engine. But I agree with Reginald here. Pluto will always be a planet in my heart. Usually, I agree with scientists, but on this one, I'm clinging to my roots. I'm clinging to my childhood. Pluto is a planet. What they taught me in kindergarten will never change in my heart. Thank you, Reginald, for reminding us of the tragedy that is Pluto being downgraded from a planet to whatever it is now, a dwarf planet or something. I don't know what it is, but anyway. So sorry to interrupt you there.
No, I love that. I was just thinking, I'm like, man, if we ever come up with some other like new graph service, it's got to have a planet name just to stick with the theme. Yeah, so I've already pre-run Louvain just because it takes a few minutes on a graph this large. And essentially what it's done behind the scenes is I already ran Louvain. So I've generated those groupings of clusters of people that tend to like the same businesses. I've already done that behind the scenes. And so each user node in the graph is going to have a property. called Louvain, which is going to contain the ID of whatever community that they belong to. So just running this query, you can see that we actually have some rather large communities. So if I really how I want to utilize this kind of community segmentation algorithm is we've already pre-generated groups of people, right? So this group with ID 90211 has like 48,000 users in it. So I've kind of already like pre-divided people into certain groups where everyone in a particular group with a particular ID is going to have similar interests. So that's generally how the Louvain algorithm works on like this type of graph model. So if we want to check out and to kind of prove that it does work, what we're going to look at is we're going to say, for each user that is in a particular group that we've already kind of pre-allocated through Louvain, like what business categories do they tend to frequent, and then aggregate the count of user visits per category. So I'm only going to take the top 20. Where's this? Sometimes my notebook gets stuck. Oh, there we go. So the top 20 most popular business categories that this particular group likes is restaurants, which I guess is a very broad theme, restaurants and food, nightlife, bars. They like to go to New American and traditional American, which in the food context, I don't even know what that means. But generally, right, like you can say like everyone in this group generally likes food of some sort, probably leaning towards American food. If we look at the different categories that a different group likes, I actually kind of picked a few out, and you'll see that they have kind of differing likes. So this other group, if we look at all the people in group 173408 and then aggregate the categories, you'll see that the people in this group tend to like kind of different things than the first group, right? Like we have a lot of maybe healthy people here because a lot of people in this group they enjoy vegan places, live and raw food, juice bars and smoothies, salads, vegetarian places. I'm not really sure why. Apparently garage store services happens to be a very common thing that they like as well. But you can kind of start to see how like different communities, if we look at the like business interactions of people in different communities, like generally you have like the American food community, you've got like the healthy food community. Here we've got like nightlife community. You can see there's a lot of people that like nightlife, bars, cocktail bars, beer, wine, music venues. All right, so you can kind of see how Louvain is able to segment off people into groups based off of their similar shared, in this case, behaviors or patterns for visiting certain businesses. So you can really kind of extend and apply Louvain to any situations where you want to be able to group nodes together based off of some similarity of how they connect to everyone else.
And I guess one thing that I have been wondering, and a lot of people may be wondering, is like, all right, so let's say that you followed along, you grabbed the Yelp data set or whatever data set that you need to work with, and you've managed to get some basic recommendations being spat out for they look like reasonable recommendations. How do you think people should think about actually integrating this into their application? I could certainly. I feel like it's pretty simple if you're integrating it into just like a standard web app, because then it's just like you take the input, you query with that input, whatever the page or product that you're already on is or that you already bought is, and then you just need to render the results of the recommendations in a web app. But I guess how would you go about integrating this into like an agent or something that you wanted to, something that was more like AI powered and autonomous? Do you have any thoughts on that one?
Yep, absolutely. So that is kind of where the Neptune MCP comes in. So, we've got all this great data and information in our graph. And as you mentioned, you could just fix an API layer over it and you kind of have like fixed queries and then just given some input, you get some output. To make it more flexible, you could have kind of like this agentic layer to it where you'll give access to the graph to the agent through a tool, for example, something like the Neptune MCP server, which essentially is just exposing a few different methods for an agent to be able to like get the schema of the graph and then actually send a graph query. So what we're doing here is we just have a really simple example of how you could do this with strands. So here I'm just passing in the Neptune MCP server, just running a local one, pass that in as a tool to an agent. And so essentially the agent is going to be in charge of kind of coming up with the correct graph query for a given natural language question, and then also run that graph query against the graph for you and then parse the results back to you.
Yep. And I imagine, like, if you haven't integrated any sort of structured query language into an AI agent before, it's worth considering. I think Melissa pointed it out. There are techniques like building an MCP or building some kind of some pretty clear LLM instructions to make sure that your agent actually can build the correct query based on whatever data model you have in this case, Neptune, or whatever the upstream graph system is that you need to query. And that nuance exists whether you're querying something in graph or typical SQL over a bunch of tables. So just something to be aware of. If it doesn't, if you just give your LLM a tool with access to Neptune, you may see it trying to use like its training data or some other data to generate a response where you might have to kind of coach it and give it more context on the sort of query patterns that it'll need to execute on. I got to say, this has been a really fun episode. Is there anything you feel like we want to show in the notebook here before we wrap things up, Melissa?
No, I mean, I think really the last thing here was just showing how you could query with the agent. You'll notice that this is a really simple query. I think more complex queries, as you mentioned, Trevor, there's strategies where you can kind of like pre-template certain queries for certain intents and then use that to kind of guide the agent. But yeah, plugging it into an agent, I think, is always a good idea. It just makes it so much easier to access the graph, and it's just so much more flexible for the types of questions that you can even ask.
Absolutely, yeah. And if you were thinking of like a natural language response, you'll probably I've seen a lot of customers, like, you see the response here that's like it looks like an LLM is reading back a query, but a lot of agents, you'll have like a final step in the agent that some people call like a communicator or like a chat step, where you take this and turn it into like, oh, I bet you would like this restaurant up the street, or whatever the result ends up being. Melissa, this was one of my favorite streams so far of the year. I felt like it was super easy to follow. It's very clear how you would apply this in the real world. And I know that you spent some hours this week conforming the Yelp data set to your will. So thanks for putting all this together for the folks that tuned in with us live today.
Yeah, absolutely. And thank you as always for having me. Had a lot of fun.
Of course, folks, if you want to learn more about Neptune, we have like I think this is the 5th stream technically we've done about Neptune in the last month. So check out the other streams that we've launched with this show. Also, if you work at a company that needs to learn more about Neptune, ask your friendly neighborhood SA or CSM or TAM about Neptune if you've got a use case for it where you feel like you need to experiment a little bit more. And we're going to keep running this database show. Keep an eye out for the future episodes that we throw out into the world. And thank you all for joining us today. It's been a real pleasure. All right.
Yep, thank you.
Bye, everybody.